Hello student. Today we will learn about the relationship between a body and the force acting upon it and its motion in response to those forces. Here is the content page of today's lessons. It is a common human instinct to observe and find the cause of anything. Almost every one of us observed that a football on a ground will remain in its position if not kicked by someone. If we apply same amount of force to move a small mass and a large mass, then the smaller one moves with more accelerations. Again, if someone fire a gun, then he experiences a force in the backward direction. All the above facts can be explained by the laws of motion given by Sir Isaac Newton. He worked out the three laws of motion governing the movement of all objects at all times and all circumstances. He published them in his book Philosophia Naturalis Principia Mathematica in 1687. These laws are well known as Newton's laws of motions. The first law states that an object in motion tends to stay in motion and object at rest tends to stay at rest unless acted upon by an unbalanced force. If we place a football in a field, it will be sitting at rest. It will take an unbalanced force of kick to change its state. Two teams are playing a tug of war. They are both exerting equal force on the rope in opposite directions. This balanced force results in no change of motions. Newton's first law of motion is also known as the law of inertia. Inertia is an object's tendency to resist a change in its state. It is a property of matter. The greater the mass, the greater the inertia. The greater the speed, the greater is the inertia. Here is the types of inertia. Inertia can be classified into two types: inertia of rest and inertia of motions. Inertia of rest is a tendency of a body to oppose any change in its state of rest. When a bus starts suddenly, the passenger in the bus fall backward. This is because the lower part of the bodies of the passenger being in contact with the floor of the bus come in motion along with the bus. On the other hand, the upper part of the bodies remain at rest due to inertia of the rest. Hence the passenger falls backward. Inertia of motion is the tendency of a body to oppose any change in its state of uniform motion. If the bus stops suddenly, the passenger falls forward. This is because the lower part of the bodies of the passenger come to rest as soon as the bus stops, but the upper part of their bodies continues to move forward due to inertia of motion. Hence, the passenger falls forward. The second law of motion states that the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of the force. If F is the force applied and m is the mass of the body and a is the acceleration produced, then we can write F proportional to change in momentum divided by time, which is equal to F proportional to mv minus mu by t, where v is the final velocity and u is the initial velocity. Now, F proportional to m into v minus u by t is equal to F proportional to m into a, where a is equal to v minus u by t is the acceleration. So if the constant k is equals to 1, then we can write F is equals to ma. Now, the examples of second law is as follows. If we write F is equals to ma as a is equals to F by m, we can see if we apply more force to an object, it accelerates at a higher rate. If the same force is applied to an object with a greater mass, the object accelerates at lower rate because mass added inertia. That's why pushing a car is easier than pushing a truck. Here, the mass of the truck is greater with the respect to mass of the car. And the third law of motion states that to every action there is an equal and opposite reaction. If we kick a football, our leg experiences an equal amount of force in opposite direction. When a bird flies in the sky, they push the air backward and the air pushes the birds forward. Hence, the birds can fly easily.